Alright, section 4.3, solving trig equations. Before we start actually solving equations, we're going to go back and review doing inverses. Specifically, these are helping us to deal with the inverses that we have to do with the calculator because they're not special ratios on our charts that we've been memorizing. Okay, so if you don't have a calculator to use, hopefully you can find one. You need a scientific calculator, and even though some scientific calculators do have an inverse cotangent on them, I really want you to try doing this without that function, because most scientific calculators only have inverse sine, inverse cosine, and inverse tangent, which is why we're doing these in particular, because these particular ones wouldn't be on your calculator if you have the normal scientific calculator, right? All right, first of all, it doesn't tell us whether we're giving our angles in degrees or radians. For the most part, you will give your answers in radians. That's just kind of what's expected in this class in particular. I know until this class you've hammered out using degrees, and sometimes we do use degrees. So if you want to do them in degrees as well, you can, but ultimately we want our answers in radians. All right. So to do tangent, cotangent, arc cotangent, what we have to do is use the inverse tangent button on our calculators. Does everyone have a calculator that's here in class with me that you can use? Nope? Okay. All right, so the first two changes I've made is I've changed my arc cotangent to basically arc tangent. And then I've taken my ratio of 2 and I have done the reciprocal of 1/2. Right? So you have to make both of those changes for it to work right. You wouldn't be able to do the inverse tangent of 2. You would not get the right answer. Now, I'm pretty sure my calculator is still in degree mode, so I'm going to go ahead and do this in degree mode to get a degree answer first, and then we'll do radians. Sometimes it's nice to see things in degrees anyway because they're less foreign to our brains. Makes more sense what's happening. So I got like 27. I'll just round it. It says 4 decimal places, but just since I'm doing it in degrees and that's the wrong answer choice anyway, I'm just going to do 1 decimal point for the degrees. But let's go ahead and do radians, so make sure your calculator's in radian mode. If you don't know how to change it to radian mode, let me know and I'll see if I can help you figure it out. Okay, so then when I did that in radian mode, I got 0.4636, because I'm supposed to have 4 decimal places, right? So that should be the correct answer. And I'm not really worried about quadrants because we had a positive ratio. So a positive ratio is quadrant 1, right? And quadrant 1 is our happy place. That means we don't have to change anything to other quadrants. It's just quadrant 1. It's between 0 and pi halves. So pi halves would be half of 3.14, whatever that is. So half of pi is 1.57. Did we get an answer between 0 and 1.57? Yes, we did. Quadrant 1. Okay, moving on. So for secant, supposing we don't have a secant button on our calculator, which one is the reciprocal? If you were thinking cosine, you are correct. So inverse cosine of 1/5. Don't forget to flip your ratio over to the reciprocal in order for this to work properly. So then in my calculator, I'm not even going to try it in degrees this time because I don't want to keep switching back and forth. So 1/5 inverse cosine. So I got 1.3694. That should be in radians. If you want to actually write down that's in radians so you're not confused about how is that possibly an angle. Well, it is. It's in radians. And again, this is a quadrant 1 angle, right? Not that we would have to worry about this, but we're going to see that in question 4. It's a quadrant 1 angle because it's a positive ratio, quadrant 1 angle. Those are the good ones, the ones we don't have to stress about. All right, and then we throw the negatives in and mess everything up. So we actually can bounce off of what we did in problem 1 to help us with problem 3. Arc, cotangent, and inverse cotangent mean the same thing, right? This one is 2, this one's -2. So the only difference that makes is changing quadrants. So when we change this to inverse tangent of -1/2, we should get a quadrant 4 answer, right? And our quadrant 4 answer that we should get is -0.4636. So try that in your calculator if you want and see if your calculator agrees with me. I'm going to try the same thing. Inverse tangent of -1/2. And I got -0.4636. That is a quadrant 4 angle between -π/2, -1.57, and +π/2, +1.57. So that is the correct answer for the inverse tangent of -1/2. However, it is not the correct answer for cotangent. Our cotangent inverse should be in quadrant 2. So what we have to do is use this as a reference angle and think of it as instead of going back into quadrant 4, -0.4636, it's going away from 180, or from rather pi, right, because we're doing this in radians. It's going away from pi that same amount. So what we're going to do is take pi and subtract that reference angle. So pi subtract, it's already negative, which doesn't mean we're going to turn it into a positive because we really are just talking about the reference angle here, which the reference angle is the 0.4636, right? So pi is 3.14, and 3.14159, however many decimals you want to do. I'm just using the pi in my calculator. 0.4636, and that gave me 2.67, and then it's a 799, so that would round that up to 680, I guess. If I'm supposed to do 4 decimal places, I'll throw a 0 in there so that I know I did round it. So cotangents are by far the hardest ones, because if you don't have a calculator that does inverse cotangents, then you have to use an inverse tangent, but then you have to change your quadrant 4 angle to a quadrant 2 angle. Like I said, I've kind of prepped you for this already in the past 2 sections, yes? So that's probably not anything you didn't already know. And then number 4 is easy, and that's because cosine and secant, inverse cosine and inverse secant are in exactly the same quadrants. We don't have to do any of this weird switching quadrants. We just plug it in as a reciprocal. We're going to get a quadrant 2 answer. And our quadrant 2 answer, what does my calculator say it's going to be? Is 2.3005. And that answer is between 1.57 and 3.14. So yes, that's a quadrant 2 angle, as it should be. When we plug in a negative ratio, we get out a quadrant 2 angle for cosine, and for cotangent, and for secant. Correct? So tangent, inverse tangent would come out as a negative quadrant 4 angle. But inverse cotangent is quadrant 2, and inverse secant and inverse cosine are quadrant 2 angles. Why was this one a quadrant 1 angle? Because that was a positive ratio. So positive ratios give us quadrant 1 angles every time. It's only negative ratios that switch either quadrant 4 or quadrant 2, and we have to stop and figure it out. Question